Okay, so today we are continuing with lesson 6. We're still talking about rational exponents. Yesterday the rational exponents were integers. Today they are going to be fractions. So here again is a screenshot from the textbook, and it's sort of showing you what the rational exponent is as a fraction. So we're going to always assume that these are going to be positive. Remember, if you try to take a negative square root or a fourth root, we can't do that yet. So if you have any negative numbers that are raised to an even root, meaning the bottom of the fraction is an even number, we're going to say that we can't do those. But if it's an odd number, we can find that root. So here again is the key concept for the rational exponent. All right, so here is an example. So here is again, we're reviewing the rules for your exponents. So remember, your product rule is when you multiply numbers that have the same base, you add their exponents. When it's a power to a power, you're going to multiply them. All right, so again, a power to a power, you're going to multiply the exponents. And then for the quotient rule, you subtract the exponents. Remember, when you have a negative exponent, it turns it into a fraction. It does not make it a negative expression. And if you have a fraction and the fraction is raised to a power, remember that power distributes to both the numerator and the denominator. All right, so here are some examples of square roots. So if I were to turn this square root into, or figure it out, notice the square root of 4 is 2. And then the little exponent up here, I would evaluate it, and it would be 2. Now, what we're going to see is it's not going to be written like this for us. You're going to be given 4 to the 1/2 power. The denominator of your fraction is the root. The top of the fraction is the exponent. So you're going to be given integers. They are going to be raised to a fraction or a rational exponent, and they're going to be fractions. And then we're going to evaluate them. Now, technically you could do the exponent first and then find the root, but I always find the root first. It makes the number smaller. So for example, on the next one, 8, and then here, the third root or the cubed root of 8, and we're looking for what number times itself 3 times would give me an 8. And that's going to be, since we've already been factoring with cube roots, we're going to find out that that number is going to be 2. So 2 is the answer here. And then I would have the exponent. And again, I would get a 2. The way you're going to see it as a question, it's going to be written as 8 to the 1/3 power. Again, the denominator of the fraction is going to be the root that you are looking for. On the next one, it's a variable, but again, we're going to just turn it into a fraction. So here you would write it as x, and it's raised to the b over a power. Yes?
Is this R6 or R7?
This is still R6, and it's day 2. All right, so my first example. So again, here we're assuming all variables represent positive real numbers. So we could actually do it, because if it's a negative square root or a negative fourth root, we can't do it. All right, so again, this one I'm going to write it now as a root. Again, the denominator of my fraction is the root I'm looking for, so it's a square root. So I'm going to rewrite this as the square root of 4 and then raised to the first power. So the square root of 4 is 2. And it has an exponent of 1, and 2 to the first power is 2. All right, next one. I'm going to turn it into a root. And notice the bottom of my fraction, the root, I'm looking for the cubed root. Or I'm looking for what number times itself 3 times gives me 27. After I find that cubed root, I'm going to square my answer. So the cubed root of 27 is 3, and then I square it. And the answer is 9. Has a negative exponent here. What did we learn yesterday about negative exponents? What does it do to it? Turns it into a fraction. Okay, so I'm going to take the 81, put it underneath the 1, and then I could write it as 81 to the 1/4 power. Now becomes positive. And now I'm going to find the 4th root of 81 and then to the 1st power. And now the 4th root of 81, that is going to be 3 times 3 times 3 times 3. And then 3 to the 1st power, and I get 1/3. We have 16 to the 3/4 power. Again, I'm going to turn it into a root. It's the 4th root of 16. And then I'm going to raise that answer to the 3rd power. So what number times itself 4 times gives me 16? 2. And then you'll do 2 to the 3rd power. And you get 8. Yes. 1,000 to the negative 2/3 power. Again, I have a negative exponent. So I'm going to move the whole thing underneath the 1. Make the 2/3 positive now. And now I'm going to turn it into the cubed root of 1,000. Get my answer, and then square it. So the cubed root of 1,000 is 10. 10 times 10 is 100, times 10 again is 1,000. So it becomes 10. I then have to raise that to the 2nd power, giving me 1/100. All right, now on this one, generally if this were in, I'm going to do it 2 ways. I'm going to first solve it the way it is. So right now, this 1/2 is only on the 100. So what I'm going to do here is put the negative sign. I'm going to write the square root of 100. And then it's raised to the 1st power. So once I evaluate this one, I would get negative 10. Now, let me show you the difference. I'm going to write a new problem. So here is a new problem. It's now in parentheses. What? That's the next one? Oh, okay, let me see. Thank you.
Wait, what if you still write in parentheses, but you put the negative like outside? Like if you put the 100 in the square, yeah.
Like that? That's fine. Okay, so, okay, it's going to be actually question number 8. So I wanted to show you the difference. So remember when you don't have a parentheses around your negative number, the exponent is only on the number. It's not combined with that negative sign. So the negative sign is just going to fall down. You're going to find the square root of 100, which is 10, and then put the negative sign in front. Let's try number 7. This one has parentheses around it. Now, when your root is an odd number, we can find the root of an odd number, but not of an even number. So number 7 I can solve, but number 8 I cannot. When I try to square root a negative number, I am going to turn it into an imaginary number. So when you see the square root of a negative number, we're not going to perform it right now. Later on, we're going to learn how to work with imaginary numbers. Yes? Okay, so you cannot find the square root of a negative number or the fourth root, but you can find the cubed root of a negative number or of an odd root. So let's go ahead and look at number 7. I am going to take the negative 64. Okay, so I'm going to take the negative 64. I'm going to find the cubed root, or the third root of it, and then I'm going to square my answer. So, what number times itself 3 times will give me negative 64? Negative 4. Because negative 4 times negative 4 is positive 16, times another negative 4 gives me the negative 64. Then I'm going to square that answer, giving me positive 16. For number 8, notice I'm going to try and take that whole 100, the negative 100, and then I'm going to try to square root that. I cannot square root a negative number, so you're going to write can't do it. Next one, we're going to find the cubed root of 27. Once we get that answer, we're going to put it to the 4th power. So the cubed root of 27 is 3. To the 4th power now is 81. 64 to the 3/2 power. We're going to find the square root of 64 and take that answer and raise it to the 3rd power. Square root of 64 is 8. 8 to the 3rd power is 512. The next one, I know it's a negative number, but my root is an odd number, so I can do this. So again, it's also a negative exponent. So I need to take the whole thing. I'm going to move it to the bottom. Make my exponent positive now. And now I'm going to write it as negative 32. I am trying to find the 5th root. And then I'm going to raise that answer to the 4th power. So what number times itself 5 times, okay? And I know that negative 2 times negative 2 times negative 2 times negative 2 times negative 2 gives me negative 32. So negative 2 to the 4th power, and it's underneath the 1, gives me 1/16. Number 12, another negative exponent. Again, I'm going to write it. Actually, it's a fraction, so I'm just going to flip it. I could put the whole thing underneath the 1 and then divide it. Remember, when you have a fraction that's raised to a negative exponent, flip it to the reciprocal. Make the exponent positive. And now I'm going to find the square root of 100 over 121. And then I'm going to cube that. Now I can also apply that property where I'm going to do the square root of 100, square root of 121, and then cube everything if you'd like to see it pulled apart.
Wait, doesn't the 3 also distribute?
Yeah, it does. So I can also do this and put a 3 here and do 121, put a 3 here and write it like that. So then the square root of 100 is 10. the square root of 121 is 11, and then I have to cube all of those, and I would get 1,000 over 1331. Now, if you'd rather just, evaluate it 10 over 11 and put the third that way, again, you don't have to show all of these steps, but just don't leave anything out. Know what you're doing. Bases. We are going to add the exponents. So this will become 6 to the 4/3 plus 2/3 power. And when I add that, 6 to the 6 over 3, which is 6 to the 2nd power, which is 36. So I will add those rational exponents, simplify them. 6 divided by 3 is 2, and then 6 squared is 36. The next one, yes? Next one is division. I have the same bases here, so I am going to take my exponents and I'm going to subtract them. So 7/3 minus 5/3 gives me 2/3. So now I have 125 raised to the 2/3 power. So I'm going to find the cubed root of 125 and then square that answer. So the cubed root of 125 is 5, and then I square it, final answer 25. So here I'm going to add the exponents. Divide 9 divided by 9 is 1. I get r to the first, which is just r. Number 16. I'm going to add the denominator. So I'm going to add 5 over 4 plus, and I'm going to make this into a common denominator. So I'm going to end up changing that to an 8 over 4, and it's negative. So when I do that, I'm going to get 3 over 4, sorry, negative 3 over 4. I'm going to do it this way. So z to the 3/4 over z to the negative 3/4. So then what I'm going to do here is I have to subtract them. So then I'm going to do 3/4 minus negative 3/4. So this becomes a plus sign, and I get 6/4. So z to the 6/4. And I'm going to reduce that to z to the 3/2. And that's my final answer there. Now, we could have done it another way, and we could have moved the 2 up to the top, added it to the top, and then subtracted. And write this in square root form. So we could say that it's z, the square root, and to the 3rd power. So these are going to mean the same thing. If it were a number, you would actually find the square root and then cube it. So if it were a number, you would do that. But because we don't have a number here, we don't know the value of z, you can leave it with the fraction. You just have to simplify the fractions and get it into one letter with one fraction. Next one, I'm going to do the power to the power. So I'm going to multiply 15 times 1/5 and 15 times 2/3. So when I multiply 1/5 times 15 over 1, I get 3. So I have r to the third power so far. And then I'm going to multiply 2/3 times 15. I'm going to simplify diagonally, and I get s to the 10th power. I still have my r squared at the bottom. I am now going to subtract my r's. I'm going to divide them. So 3 minus 2 gives me r to the first power. So r s to the 10th. So for 18, I am going to multiply 3 times 1/4, and I will get p to the 3/4 power. The bottom, I'm going to multiply p and get 10/4. Now, I could simplify that and make that 5/2, but remember, I got to subtract here. So I'm just going to leave so I have a common denominator. So I'm going to subtract 3/4 minus 10/4, and I get negative 7/4. So p to the negative 7/4. I need to make that exponent positive, so I can go ahead and show that it equals 1 over p to the 7/4 power. Okay, so your homework is you're going to look for the R6B. It's page 63, 47 through 69 odd. And again, the solutions for section 6 are still in the same file that you used last night.